1, Lesson 1, Adding and Subtracting Polynomials. Sorry, my voice is not fully back, but it's a lot better than it was, so we'll roll with it. A polynomial, I'm just going to jump right into it. It's a monomial, or the sum of monomials, each called a term. Okay, some polynomials have special names. For instance, a binomial is a sum of two terms, and a trinomial is a sum of three terms. The degree of a monomial is the sum of the exponents of all of its variables. So, when it has a degree of 0, it's considered a constant. 1 is linear, 2 is quadratic, which that's the one, the graph looks like this or like this, but that's what we're going to be focusing on for the next few weeks, quadratics, cubic, quartic, so on. The degree of a polynomial is the greatest degree of any term in the polynomial. You can find the degree of a polynomial by finding the degree of each term, and polynomials, I apologize. I couldn't stop that yawn from happening. It just happened. Polynomials are named based on their degree. So we're going to identify polynomials in this first example. So it says determine whether each expression is a polynomial. If it is, find the degree and determine whether it's mono, binomial, or trinomial. So this first one, 4y minus 5xc. Oh, I thought I was on highlighter. This is a polynomial because it is the sum of two terms, okay? The degree, I don't agree with this. The degree is 1 because there are no exponents, but there are variables. So the variables of those exponents would be 1. And this is a binomial because there are two terms being added or subtracted together, in this case subtracted. The next one, negative 6.5. Negative 6.5 is a polynomial. Negative 6.5 is a real number. The degree is 0. There are no variables with this, so the degree is just 0. And it is a monomial because it's just one single term. This next one, 7a to the negative third plus 9b. This is not a polynomial at all, okay? This is due to the fact that it is going to be 7 over a to the third, which is not a monomial. The division part kind of just doesn't work out with monomials. So there's no degree to mention. It's not a binomial or trinomial. It's a rough start here to this video. The next one, last one in this example, 6x to the third plus 4x plus x plus 3. It is indeed a polynomial. The degree is 3 because that's 6x to the third. That's the highest power that is listed. And it is a trinomial because we can simplify this 4x plus x. We can simplify it to 5x. We can combine those like terms there. So the terms of a polynomial can be written in any order. However, polynomials in one variable are usually written in standard form. The standard form of a polynomial has terms in order from greatest to least degree. In this form, the coefficient of the first term is called the leading coefficient. So in this, the leading coefficient is 4, the greatest degree is 3. So example 2 is going to ask us to write each polynomial in standard form and identify the leading coefficient. If you guys are wanting to pause your videos and try these on your own, please feel free to do that. Rewind, fast forward, whatever you guys need to do to be successful. So I'm going to go ahead and look at part A, standard form. So I'm looking at this. This is our highest degree right here. We've got 2, 5, and 1, but 5 is the highest degree. So I'm going to write that 4x to the 5th first. And then I'm just counting down from here. So 3x squared plus 3x squared minus 7x. Okay, so there it is in standard form. The leading coefficient is that first coefficient, which is 4. Part B. So I'm going to look here. The highest degree is this 4 right there. Make sure you keep your signs with it too, because that's a minus 2y to the 4th, so it's going to be negative 2y to the 4th minus 6y to the 3rd plus 5y minus 9. So your leading coefficient here is negative 2. So that's standard form of polynomial. Let's scroll down to example 3. Now we're going to get to the main topic here, which is adding and subtracting polynomials. So this first example 3 is talking about adding polynomials. And there's a couple ways to do this. You could do the horizontal method where you group like terms, or you can do the vertical method where you line it up. So I'm going to try both of these using different methods. So horizontal method is going to look like this. We're going to make sure that we remember what like terms are. Like terms have the same variable, but also the same power. So what I'm going to do is I'm going to first just take my little highlighter here, and I'm going to highlight like terms. So here's 2x squared, negative 4x squared. Grab a different color. Then I've got plus 5x plus 6x. And then my last, I've got minus 7, and then I've got a 3 there. So when I go through, I'm going to group, I'm going to get way too colorful with this, but I'm going to group my 2x squared minus 4x squared. And then I've got, what, blue now? I'm going to turn this one into blue. I'm a little excessive. So now I've got plus 5x plus 6x. And then my last one, oh, it's more purple. So I had that one. And then I've got a negative 7 plus 3. So all in all, let's just finish this out with a good rainbow of all of these. So 2x minus 4x squared is going to be negative 2x squared plus 5x plus 6x is 11x. And then negative 7 plus 3 is negative 4. So there is our sum. That's a beautiful box. There is our sum of our polynomials. All right, part B is going to list it in the vertical method. So vertical method only really works if you have it in standard form. So what I'm going to do is I'm going to list out my polynomial in standard form. So I'm going to say y to the third. I'm looking at that first polynomial. I'm going to leave a spot open for y to the second because I see that there's a y to the second here. So I'm going to say 0y to the second, just leaving a spacer basically, plus 3y minus 5. And I'm saying we're going to add all of these things to the bottom. So 2y to the third, line up your like terms. We've got 4y squared minus 4y plus 8. Okay, what's nice is since we're adding this, adding a negative on this little 4y down here, adding a negative is just like subtraction, so I could just go straight down and not have to worry about distributing any signs. So y to the third plus 2y to the third is 3y to the third. 0 plus 4 is going to be 4, so 4y squared. 3 minus 4 is going to be negative 1y, so just negative y. Negative 5 plus 8 is going to be plus 3. So there's the vertical method, which is just like adding, it's just lining it up and adding it. You can also do that with subtraction. So we'll look at both the examples here. So we've got horizontal method for find each difference in example 4. Horizontal method, I'm going to pair up all of these terms. And then 3 and negative 5. So what I'm going to do is I'm going to focus on the highest power first. I'm going to try to keep it in standard form as I go. So I'm going to say 2x squared minus 3x squared. We're going to have to be very careful with this one. So negative 2x minus 4x. And then the last one, 3. So plus 3 minus negative 5. All right, so this is really going to end up being 3 plus 5. So that last term is going to be 8. So 2x squared minus 3x squared is negative x squared. Negative 2x minus 4x is going to be negative 6x. And then we've got this plus 8 at the end. So overall, let's do our rainbow again, guys. Negative x squared minus 6x plus 8. All right. And just like the last example, or adding them, we can do the same thing with subtraction. So standard form. Let's write them in standard form. So I've got 4p to the third plus 0p squared, because I'm going to have that placeholder, plus 7p minus 8. Now something very important is we're going to put a minus sign out here. So I'm going to be subtracting all of the stuff inside, so that might mean I have to distribute that negative into these. I do need to distribute the negative. So we don't have any p to the third, but we do have a 3p squared plus or minus 9p plus 2. Okay, when you're doing this method, pay attention to your negative out here. It's going to be distributed into all of these parts. So the signs are going to change. So 4p to the third, there's nothing there underneath it, so 4p to the third is what it's going to be. I'm going to have 0p squared, so nothing, but I have a negative 3p squared. 7p minus a negative 9 is going to end up being a positive 16p. And then we have a negative 8 minus a positive 2. So negative 8 minus 2 is going to be negative 10. So there is that subtracted. Beautiful boxes I've got going on here. So you can use horizontal grouping methods, you can use the vertical method, that's up to you, as long as you are making sure to add the like terms together. Otherwise, it's not going to work out for you. We have one more example here. Example 5 says the equations P equals 7m plus 137, I'll highlight important info, and C equals 4m plus 78 represent the number of cell phones, P, and digital cameras, C, sold in M months at an electronics store. Write an equation for the total monthly sales, T, of phones and cameras. Then predict the number of phones and cameras sold in 10 months. So we've got, first of all, total monthly sales is going to be the number of phones plus cameras. So what I'm going to do is I'm going to substitute phones and cameras in there. So total is going to be 7m plus 137 plus 4m plus 78. And I'm going to go through and I'm going to combine like terms. So I've got this 7m and 4m, which is 11. And then I've got 137 and 78, which is 215. So there's my total. Okay, so there's part 1 of this question. We have 11m plus 215. So now it says predict the number of phones and cameras sold in 10 months. So what I'm going to do is I'm going to substitute m. I'm going to replace it with 10. So total 11 times 10 plus 215. That's going to be 110 plus 215. So that's going to be 325. So 325. And it's just talking about combination of phones and cameras. it's not specifically saying how many phones and how many cameras. And that's it.